This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. At higher level, you will also be asked to study the concept of a proof by contradiction. So first of all, why do we use proof by contradiction? Well, sometimes we cannot directly prove that a statement is true. However, we can show that the statement cannot be false. This is known as proof by contradiction. We prove that a statement or assumption is true by showing that the statement or the assumption being false would imply a contradiction or an impossibility. So here I'm going to go through an example for proof by contradiction, which is to prove that the square root of 2 is an irrational number. So just to remind you, an irrational number means that you cannot express the number as a over b, where a and b are integers. So that is what it means to be an irrational number. So what we're going to do is to assume that root 2 is rational, which means it can be written in the form p over q, where p and q are whole numbers and q is non-zero, because we don't want any nastiness with dividing by 0. And we also assume that pq is simplified to its lowest terms. What we do next is we square both sides of this equation. So we have the square root of 2 squared is equal to p squared over q squared. So the square root of 2 squared is just 2. So that means that 2 is equal to p squared divided by q squared. If we multiply both sides by q squared, q squareds cancel on the right, and we're just left with 2q squared equals p squared. That means this implies p squared is an even number because it is equal to 2 times something, the 2 times q squared. Anything multiplied by 2 is going to be an even number. So that means we can say p is equal to 2 times k. So p must be even, as it cannot be odd, because p times p is even. P squared is even. So for p times p to be even, p itself must also be even. So what we let p equal to is 2 times some other variable k. So now if we substitute that value for p into this equation up here, on the left we still have 2q squared, but on the right, instead of p, we're going to write 2k. So we have 2k squared. Squaring out the right hand side, we have 4k squared is equal to 2q squared. So that means q squared is equal to 2 times k squared. Therefore, q squared is even because it's 2 times something, and if q squared is even, that means q is even. So we can write q is equal to some number, let's call it n times 2. So what that means is that our original p over q, well, we wrote p is the same as 2k, and we wrote q is 2n, But our problem here is we have these numbers 2. We have a contradiction because we said PQ must have no common factors because we assumed it is in its simplified to its lowest terms. But this clearly isn't, because we could just cancel these 2's. So it's not in simplified form. So therefore, root 2 cannot be rational by proof by contradiction, because we assumed something, and by making that assumption we arrived at a contradiction. So therefore root 2 cannot be rational, so therefore root 2 is an irrational number. And just like any other proof, we finish with our QED.